This video is going to walk you through the steps to model a building in xGenerative design with the new 3D Generative Innovator Role, an online 3D generative modeling solution from Dassault Systems. We're going to start on a new clean dashboard. I've made a tab, new xGen tab. We're going to drag and drop the application onto the dashboard in its widget form, and then we're going to do a quick search for a site. In order to reuse this search later, we're going to pin the results to the dashboard, and then I can drag and drop that part into my widget. You'll see now this is an existing site that I've generated in one of the rich client applications using the Concept Building Designer role. I'm going to activate the 3D shape so that I can start to model within that shape. I will then maximize the widget and begin. The first step is to make a point. This point will be by X, Y, Z coordinates, and I'll position it in place. Then I'm going to make a circle. The center of the circle is going to be the point. The support will be the XY plane. And now I'm going to add a slider to control the radius of this circle. By adding a minimum and maximum value and then toggling the Show Slider button, I have access to a slider that's going to control the radius of my circle. I click OK and I've committed that. Now I'm going to make 2 points on the circle by length. Again, I'll manipulate them into place using the interactive controls. At this point, I'm going to open the design sequence graph and continue modeling in the graphical scripting environment. I'll start by undocking the specification tree so that I have a clearer view of the geometry. And now I'll make a line tangent using the circle and the point as inputs. I'll make a second line. And it looks like my initial points were hiding one on top of the other, so I'll move them around. So I have a cleaner graph and an easier view of what I'm modeling. Now to control the length of our lines, I'm going to make a slider again and duplicate it so that I can use a second slider to control the length of the second line. At this point, I need to split the circle so that I can create one continuous curve. You'll see though that in order to use the split operator, I can't just input a list. Instead, I need to assemble those two lines into one geometric object and use that assemble to split my initial circle. Now I have 2 line segments and an arc, and I'm going to assemble those again so that I have one continuous curve. Now I've assembled my curve, and I'm going to do a parallel curve on the XY plane to offset that curve. Again, I can extract the offset value to create a slider. And now I'll blend those 2 curves together. Now I have a base surface. I want to slice that surface into patches. So I'm going to divide my initial curve, and I will call out that parameter, the number of divisions, as the number of towers that are going to be extruded from that base surface. Next, I'll make normal planes using those division points and my curve. This is where you see the power of xGenerative design to work with collections. I've just created one plane operator, but that plane operator has generated multiple planes based on the number of points as inputs. Now I'm going to intersect that base surface with those planes and slice the surface into sections. Every operator has a visual control, so you can hide and show the geometry. Now using the cross highlight, I can see that the order of my surfaces are backwards. I'm going to invert the order of my divide curve, which will change the order of all the children from that operator. And now my slice surfaces are in the correct order. Now I'm going to model the calculator that will compute the heights for my different buildings. And I'm going to use the curve evaluator node to help me make more interactive controls. In order for the curve evaluator to know how many outputs to compute, we're going to use a sequence node and link that sequence node to the number of towers global parameter that we've set. Then the sequence will output a list of numbers from 0 to 1 that will feed into the curve evaluator to control the heights of our building. One thing that's very important in xGenerative design is to make sure that the size of your collections match within a given operator. Matching structures is an essential part of modeling in xGenerative design. This is a relatively simple structure, a flat list of elements. As you build more and more sophisticated models using collections of multiple dimensions, data flow management becomes a critical element of your model. Now that I've linked the curve editor to my thick surface value, manipulating that curve editor is going to change the values of my extruded heights. I want to add an element of random variation to these heights, so I use the random operator. I'm going to pull out my max value and broadcast that parameter as a global parameter that can be shared and can be accessed later from the control panel. And then this random value is going to add variation to my thick surface. So I'll add the output from my curve evaluator to the random output. And now you see there's a bit of randomness to it. But this is only added random in the positive direction of my extrude. I want to add random to the negative value as well. In order to do this, I'm going to decorate the input of my random value with a formula, which is minus x. In this case, that's saying that the input is going to be negative instead of positive, x standing in for the value of the input. And because I want 10 to be the maximum variation, I'm going to divide the input by 2. So for the minimum case, it's a minus x divided by 2. For the maximum, it's just x divided by 2. And if I ever want a new random value generated, I click New Seed, and that's going to generate new values. This is all still connected to the curve editor. So any variations to the curve editor is going to generate new geometry. Based on the update sequence of the graph, you'll notice that even if I update the curve evaluator, the random generator is not changing. The only way I'll get new random values is if I click on the new seed. One thing I want to ensure when I'm building this model is that the heights of the extruded thick surfaces is in line with the floor-to-floor height of my building so that I don't have random heights sticking up. So in order to test this, the first thing I want to do is show where those floor levels are. So I'm going to make a quick line at the origin of the model, and I'm going to define a parameter that represents my floor-to-floor height. And I'll set this range between 3 meters and 4 meters. And here you see the outputs. Make sure that this is done with boundary conditions included, and I'll broadcast that parameter. Now I'm going to make planes normal to that curve using those points as input. And because I don't want to intersect all of my thick surfaces, I'm going to make a quick Boolean add volume that I will intersect with those planes. And here you see that the heights of my buildings don't necessarily correspond with the even floor spacing. So now I'm going to make a couple of nodes that's going to even out outputs from the curve evaluator to be multiples of my floor-to-floor height. So the first thing I'll do is I'll divide the output of the curve evaluator with my floor-to-floor height. I will round that number to the nearest integer, and then I'll multiply it again by the floor-to-floor height. That's going to give me an approximation of the actual curve value output. And when I replace the thick surface value with my new rounded value, you see that now the extruded heights of all of my buildings match that floor-to-floor height. I'm going to add the pedestrian walkways to the volumes now. And so I'm going to select the group of nodes that I just created and copy and paste them, because I'm going to use these as an input into my thick surface in the opposite direction to lift them up just a little bit off the ground. The heights of these pedestrian walkways are going to be linked to the random values that I've added to the curve evaluator node. So I'm going to divide that value by a 3, and now I'm going to use the results of these rounded values as an input to my thick surface. I need to decorate that and make it a negative number so that it will raise everything up off of the XY plane. But I don't want this to apply to every single extruded tower. So I'm going to create an odd and even node that's going to allow me to alternate between list outputs. And I'm going to build a new list that alternates between 0 and the results of my rounded multiplier. So I need to make a length node that's going to represent my 0 height extrude, and I'm going to mix those values into one list. I'm going to generate a new list using the mix operator. And now combining my 0 with my even values, I'll have an alternating list. However, the structure is still not compatible. It's not the same size as my number of extrudes. So I'm going to try to fit these cyclically so that I match the same structure size between the two list inputs. Now I have alternating values that create my pedestrian walkways. Navigating back to the beginning of my model, I'm going to rename that initial base curve that I created so that I can easily find it later on while modeling. And I'm going to make an extrude in the XY direction. This base surface is going to be an input to normal lines that I create to control the affinity scaling that I'm going to apply alternatingly to my thick surfaces. I need a center point as the origin for the scaling, so I'll make the center point node, and then the odd and even operator again is going to alternate between my thick surfaces that have already been generated. I'll select the even output from the odd even node as an input to my center node, so I'm only creating alternating points where necessary. I make a project, and I'll project the center point onto that base curve. Again, because it's broadcast, it's easily accessible without navigating all the way back to the beginning of my model. Now I'll make a normal line from my extruded surface that will act as an axis for my affinity. I didn't actually need that projected point. I can use the center. And now I'm going to use the affinity operator to scale the volumes that I've selected with my odd even operator. Looks like the Z value isn't what I'm looking for. The Y value isn't what I'm looking for. The X value is what I need. And I need to remember to input the center point as the axis point, or the origin of my affinity scaling. You'll see this most clearly as I rebuild my initial list, combining the odd unmodified thick surfaces with my affinity modified thick surfaces. There I connect the center point as the origin of the affinity, and the scaling is applied from the appropriate origin. Now the building massing has been complete, and we can start working on the canopy sections that are going to cover the roof terraces of this building. Before that, I'm going to name all of the important parameters that are going to drive the design of this model that will be accessible later from the control panel. These are the very first parameters that we created that control the radius and the two lengths of each wing of the building. I'll call that building radius, building length 1, and building length 2. I broadcast them, which removes the dark visible lines that connect these parameters with their children, and creates dashed lines once the output of that parameter has been activated. And I create a region around those parameters so that they're easily grouped into one area. At this point, I'm going to take a few seconds to just have a look at the model. The canopy is going to be a bit more complicated to make because we're going to have to do more list management in order to use the proper lines to generate our lofts. So the first thing we're going to do is translate those intersect curves that we created in the beginning. We'll translate them in the XY direction. And we'll broadcast a parameter that's going to control the height of the edge of the canopy from the top of the roof terraces. So that parameter is input into a plus parameter, the plus that defined the height of the thick surfaces that were output from the curve editor and the random. I have a problem with my list sizes here. I see that the number of distances do not match the number of lines that need to be translated. So I will remove the last curve now. Now I'm going to shift those values one index to the right, and I'm going to select the larger of the two values. This way the canopy surfaces will always find themselves above the thick surfaces. Now the first value needs to be duplicated, so I'm going to replace that shifted value with my lowest value from my initial list. So I'm going to use the replace item node. I need to get items from the different lists. So I'll get the first item from the select, and I'll get the first item from the displacement values. I'll feed them into the replace item node. Now you see that the first value is the correct value. The last value is the highest value. And because the canopy needs to extend over the last volume, we need to repeat that last value in this list. I'll try the fit cyclic. No, that didn't work because the fit cyclic list operator just repeats the list from the beginning. But I don't want to do that. I actually want to do fit longest. The fit longest list operator is going to repeat the last value. Now I'll use those values to translate all of those curves from the XY plane up above the building. Now if I rotate around, you'll see that all of the lines are in the correct place. The grouping node is now going to allow us to group this list into sublists. Lists that will be fed into the loft operator so that we're not generating one continuous loft, but groups that are aligned with the number parameter that we've extracted from the group node. I want to add a little flare to this canopy. I want it to be arched rather than straight line segments. So I'm going to create points on those lines, and I'll make those points by ratio using the 0, the midpoint of 0.5, and the endpoint of 1. I'm going to translate the middle point up using, again, the XY plane as the direction. And I'll extract the height of that translate to represent the height of the canopy arc. I'll give it a maximum and minimum value. In this case, 10 millimeters will be the minimum, which will appear to be a straight line, and 5 meters will be the maximum. And now I can make a circle by 3 points, which will result in an arc. And now I'll just replace those lines with my new arcs and modify the input value, and you'll see that the canopies have now updated. At this point, I can experiment a little with the design, changing the values of those points on curve by ratio so that I achieve a slight overhang without going overboard. Again, I'll hide my geometry and do a little graph cleanup so that it's easier to navigate this graph in the future. As I've done with other broadcast parameters that I'd like to have in my control panel later, I'm going to select my Canopy parameters and move them into my controllers region here. And now I'll start to do a little cleanup and create more regions that define different logic portions of my model. I'm going to pull out one last parameter, and that's the seed Boolean. When this Boolean value is triggered, a new seed in my random operator will be generated. And I want this to be a controller in case I want to explore different design options. This region is where the massing operators are. And these nodes represent the height calculations. Finally, I'll group all of the base geometry that was generated in the very beginning into one region. And I'll remove the references node. As an added touch, I'll give each one of these regions a color. And save. The very last step in this model is to publish any geometry that you would like to use later in one of the native applications in the rich client. So here I'm going to publish the individual thick surfaces. I'm going to publish each individual loft. And finally, I'm going to assemble those loft surfaces into one object and publish that assembled surface as well. And with that, our building model has been completed. I hope you've been able to follow along as I've introduced xGenerative design in the new 3D Generative Innovator role, the new online 3D generative modeling solution from Dassault Systems. Thank you for watching.